Hello students, I'm here again with another video from the chapter Electrochemistry, and in this video we will going to talk about the Nernst equation and we'll try to learn the applications of it. So in last video we talk about electrode potential, standard electrode potential, right? So it is the tendency of any electrode to lose or to gain electrode or to oxidize or to get reduced. Now standard electrode potential, so every time it is measured or calculated when the concentration of the solution is 1 molar and the pressure as 1 atmosphere, right? Now this electrode potential, cell potential, these depends on the concentration of the electrolyte. Now what about the electrode potential when the concentration of the electrolyte is not 1 molar? If it is other than 1 molar. Now the problem was solved by the Nernst equation. He gave the Nernst and he gave the relationship between the concentration of the electrolyte and the electrode potential. Now for any general electrode, so let us take, every time we have to write the equation, whatever oxidation in reduced form, right, according to the present convention. So now Nernst for this equation or for this electrode, what is the Nernst equation? Nernst equation is given by, or it can be expressed as electrode potential is equal to standard electrode potential minus RT by NF ln concentration of your metal right side divided by concentration of the left, that is your metal ion. Now what is R here? R is universal gas constant and its value is 8.314 joule Kelvin inverse mole inverse, T temperature, N number of moles of electron gained, F Faraday, which is approximately equal to 96500 coulomb, or it is the charge carried by 1 mole of electron. Now this ln is natural log. Then how this is related to the log with base 10? So ln is equal to 2.303 log. So how can we write this equation again? E m n plus m is equal to E naught minus RT. This is 2.303. So 2.303 in front, RT NF log ms by m plus n. Now at 25 degrees centigrade of temperature, when we substitute all the values and every time the concentration of solid is taken as unity, so what we can write? mn by m is equal to E naught mn plus 2m minus 2.303. R is 8.314. Temperature 25 or 298 divided by n Faraday 96500 into log. The concentration of solid is taken as 1 divided by concentration of your metal ion. So after multiplying, dividing, we'll get as 0.059 whole divided by n log 1 by concentration of your metal ion. So this is your Nernst equation for any electrode at any concentration. Now let us discuss what are its application. Again, the Nernst equation for any electrode where this reaction is taking place is your electrode potential is equal to standard electrode potential minus 0.059 divided by n log 1 by concentration of your electrolyte at 298 Kelvin. Now application. So one of the application is calculation of cell potential using Nernst equation. Now let us try to calculate cell potential at any concentration for the Daniell cell. And Daniell cell, it consists of 2 electrode, zinc electrode and your copper electrode. So zinc electrode here is your anode and this one is your copper electrode cathode. So at anode, what is the reaction taking place? Oxidation. So zinc will get oxidized after losing 2 electron. So it's reduction form. So for Nernst we need this reduction equation, right? And at cathode, what is the reaction taking place? Reduction. Your copper will get reduced after gaining 2 electron to copper solid. Now what is the Nernst equation for your anode? For anode, Nernst equation is given by here, this is your Nernst equation. Anode, electrode potential of your anode. So anode is your zinc electrode. Standard electrode potential, it's standard electrode potential minus 0.059 divided by N. Now here the number of electron gained by zinc is your 2. Zinc ion is 2 and log and concentration of your ion. Zinc ion, the metal, it is considered as 1. And what is for cathode? What is Nernst equation? Is given by E of cathode equal to standard electrode potential minus 0.059 divided by 2 log metal, it is 1 divided by your ion. So ion electrolyte is your copper. Now what is your cell potential? Cell potential is your electrode potential of cathode minus electrode potential of your anode. Now E cell, this is your E cathode minus E anode. Your cathode is your copper electrode, anode zinc electrode. Now what is your electrode potential of copper? Standard electrode potential minus 0.059 divided by 2 log 1 by copper, concentration of copper minus ion, and for that zinc it is standard electrode potential of zinc electrode minus 0.059 divided by 2 log 1 by concentration of zinc ion. Now when you open the bracket, so keep this standard electrode potential in one side, so minus E naught of Zn plus 2 to Zn, and among the two, what is the common? What is common between them? 0.059 divided by 2, right? Then log 1 by concentration of copper ion. So it is plus when you take plus or minus, or when you take minus common. So plus minus common in the minus. So log 1 divided by concentration of your zinc ion. Right? Now this is standard electrode potential of cathode and this standard electrode potential of your anode. Right? So what is this then? Difference of the two is called E naught cell minus 0.059 divided by 2. Now log. So this is your log A minus log B. Now what is log A minus log B? Log A minus log B, this can be written as log A divided by B. Okay, sir? Now, so log A is this one, 1 divided by copper ion divided by 1 divided by your zinc ion. This is your E cell. E naught cell minus 0.059 divided by 2 log what you will get after solving this one? Divided by concentration of your copper ion. Now this is your cell potential of galvanic cell at any concentration of your electrolyte. Similarly, so this is your Nernst equation for galvanic cell, where 2 is number of electron exchange, number of mole of electron exchange, and this is at your 298 Kelvin. Right? So similarly for any cell where the general reaction is given by, like this redox reaction is taking place. Now how can we write the EM of the cell? So this is equal to E naught cell. So zinc is cathode, copper is anode, or zinc is at. Now this was the reaction taking place in galvanic cell at anode, at cathode. When what is the overall reaction then? Zinc plus copper ion, zinc ion to and copper, right? Now this zinc is on right side. So timro right side every time timro numerator ma huncha र left side ko ion will be at the denominator. Again right side ko ion numerator and left side ko ion denominator. By anode, this is electrolyte of anode, numerator, electrolyte of cathode, denominator. So for this cell, so how can we write E cell? This is equal to minus 0.059 divided by n log, right? Concentration at the right side. So your C is there, D is there. So concentration of C, and this is your coefficient. You need to take this as power C, and concentration of D to the power D, right? Divided by, now this is at left side, concentration of A to the power A, concentration of B to the power B. So this is the Nernst equation for any cell, any type of cell. Now let us take this cell and let us try to find out what would be its E cell according to Nernst equation. So this is your anode, left side, and this is your cathode. So what is the reaction taking place at anode? You need to write down the reaction in order to find out what is the value for N. So anode, oxidation Ni will get oxidized to Ni plus 2 and 2 electron. And at cathode, your Ag plus get reduced after gaining 1 electron to Ag. Okay. Now, eta electron le nickel. So it is releasing how many electron? 2 electron, right? So you need to balance the equation. So it has to gain 2 electrons. So to that, we have to multiply this equation by 2. So 2, 2 and 2. So what is the number of mole of electron exchange during the reaction? It is 2. Okay, now what is the overall reaction taking place? Overall reaction. This is your, add the two equation. So nickel solid and silver ion on same side gives nickel ion and silver on the other side. Now what is Nernst equation? Nernst equation. So it is equal to E cell is equal to E naught cell. Okay, sir? Minus at 298 Kelvin minus 0.059 divided by N. So number of mole of electron exchange out here is 2. So 2, then log concentration of anode by concentration of cathode. So right side divided by left side. So right side ma, so you need to take the ions because concentration of your metal is every time taken as unity. Right? So your unity by, so right side ma yo cha anode yo ho divided by Ni plus 2 divided by cathode or left side. This is your solid 1. So isko concentration. So Ag plus and यसको कति छ what is the coefficient 2 so तिम्रो 2 will become power this is your E cell for this electrode okay now next now let us try to solve this problem okay so this is the equation taking place in the cell given to you concentration is given to you so you need to represent this cell depiction then you need to calculate E cell and E naught cell is given to you okay now so first you need to identify the anode cathode so anode ma every time oxidation huncha and cathode ma reduction okay so this is your anode so at anode oxidation takes place so what is your anode oxidation so your metal this is getting oxidized so Mg plus 2 concentration is 0.130 molar plus दुईटा electron किनभने plus 2 charge कहिले पाउँछ when it loses 2 electron at cathode what is the reaction taking place here Ag plus 2 plus 1 sorry 0 point of this concentration got reduced after gaining 1 electron to Ag now 2 electron loss hunदैछ माथि so it need to gain 2 electron okay so this is the reaction taking place at cathode now what is cell representation so here n is equal to number of mole of electron exchange 2 यो याद गरिहाल्नु नोट गरिहाल्नु now cell representation salt bridge anode cathode at the left so anode is here this isn't it where the oxidation takes place and the change is from magnesium to magnesium ion and your cathode where reduction is taking place Ag plus to Ag so no need to write your 2 coefficient out here okay so 0.0001 molar so this is your cell representation now next question is you need to calculate EMF of the cell now what is E cell so E cell is equal to E naught cell minus 0.059 divided by n log concentration timro anode which one is your anode magnesium so concentration of your anode divided by concentration of your cathode भयो so anode right side divided by cathode metal ko jaile pani 1 huncha so what is the coefficient there is coefficient for silver right so you need to take this as power right so what is E cell E naught cell so it is given to you it is equal to 3.17 volt minus 0.059 divided by n is 2 log concentration of magnesium well, we can write this as 1.30 divided by into 10 to the power minus 1 divided by 1 into 10 to the power 1 2 3 4 minus 4 so E cell this one into 10 to the minus 4 whole square okay sir now when you substitute the value so this can be written as this form 1.30 so this is minus 8 when this goes up plus 8 okay and minus 1 sorry so plus 8 minus 1 garda you will get here 7 okay now when you do the multiplication now this is log so I'll again explain you this in another video okay I'll you tell you how to do the log and all log and log how to find out now so here the log this is a into b so log a into b can be written as log a plus log b okay now log 10 to the power anything we can write this 7 log 10 now what is log 10 it is 1 so this value so we can find it from the log table okay after using log table the value of this one is 0.1139 plus 7 okay now when we do the calculation multiplication addition will come like we'll get the value as 0.21 around approximately this one minus this value when you subtract the two you will get the value for E cell as 2.96 volt so this is how so we can calculate E cell from Nernst equation for any cell at any concentration. Thank you.